Hi everyone. So today I'm trying to do a lead code problem after a really long time. So let's see what's the question. Today's question is 1514 path with maximum probability. Okay. Um, so I'm also looking at this question for the first time. I think I've not done this question before. Yeah. So let's do it together. So I'm also doing this, on new lead code question probably after when was the last time I did? Maybe probably after a month and a half, or like I have to see my last YouTube video to know when I did my last lead code problem. Yeah. Okay, so let's start the question. 1514 path with maximum probability. You are given an undirected weighted graph of n nodes, 0 indexed, represented by an edge list, where edge I is equal to AB is an undirected edge connecting the nodes A and B with the probability of success of traversing that edge. Success probability I. Given two nodes start and end, find the path with the maximum probability of success to go from start to end and return its success probability. If there is no path from start to end, return 0. So we are given n is equal to 3 and we are given edges. So success probability is also given, right? 0.5. It means that from if I go from edge 0 to 1, then the success is 0.5. If I go from edge 1 to 2, then the success rate is 0.5. If I go from 0 to 2, the success rate is 0.2, and the start is 0 and the end is 2. So it means that I need to go from 0 to 2. I think I need to follow some path, right? Path with maximum probability of success. Okay, so I need to go from 0 to 2. I need to find the path that will provide me the maximum success. Okay, and the graph is undirected. It is not directed. I can go from 1 to 0 or 0 to 1. Okay, and if there is no path from start to end, then I need to return 0. Okay, so what is the way to do this? I'm not sure. Let's look at another example. There are 3 examples given. Nice. Are there any constraints? So n is, so it means that n is at least 2. So there will be at least, what is n? N is nodes. So there will be at least 2 nodes. And nodes can be 10 to the power 4. And start and end. So start can be go from 0 to n. Start to end. Okay. It means that the node starts from 0, right? So start can be from 0 and end. So start will not be negative. I mean, the node cannot be negative. That's what it means. And end will be less than n, obviously, because there are n nodes. And I mean, there are n nodes. So suppose if there are 2 nodes, then start will be 0, and if there are suppose 4 nodes, then I mean, if n is equal to 4, nodes is equal to 4, then node name will be 0, 1, 2, 3, right? So what this means is start and end can be any number from 0 to 3. That's what it means. And A and B is, so this A and B, right? So this is A and this is B. Is, so if A and B can be, it also can be from 0 to 3, right? If n is equal to 4. So that's what it means. And A is not equal to B, so it will not be from, so this problem will not give us ages where A and B, they are both equal. It will not give us ages like that. A is not equal to B, and success probability length is equal to ages dot length. So this success probability length will obviously it will be equal to this. Okay, and probability I will be from 0 to 1, obviously, right? Probability value will be from 0 to 1. Okay, and there is at most one edge between every two nodes, obviously. Nice. So there will be at most one edge. There will not be more than one edge between two nodes. Okay, nice. Okay, so let me try to find a solution for this question. If this is 0 and this is 0, this is 1 and this is 2, and there is another is here as well. So in this condition, just a second. So in this condition, how can I find the maximum probability? How will I know? I need to go from 0 to 2. So is the probability value, like if I go from 0 to 1, suppose if I go from 0 to 1 and 1 to 2, then what is the probability of success? If I go from 0 to 1, it is 0.5. If I go from 1 to 2, it is 0.5, right? So 0 to 1 is 0.5 and 1 to 2 is 0.5. So if I go this way, then what will be my probability? Will it be multiplied? 0.5 into 0.5 is equal to 0.25. Will the probability be multiplied or will it be added or what? Let me think. If I go from 0 to 1, it is 0.5. If I go from 1 to 2, it is again 0.5. So I think that it is multiplied. And I need to find the maximum probability, right? And from 0 to 2, it is 0.2. Yeah, I think that is the case. So yeah, so there are two paths from start to end. One having probability of success is equal to 0.2, that is going from 0 to 2, and another one is when I'm going from 0 to 1 and 1 to 2, this one. Okay, nice. So I will multiply it. Okay, this question is, I think this example was fairly easy to understand. Let's see. So here there are 3 nodes and the ages are from 0 to 1, 1 to 2, 0 to 2, and success probability it is 0.5, 0.5, 0.3. It is like okay, and start is 0 and end is 2, right? So if I go from 0 to 1, 1 to 2, it is 0.25, 0.5 into 0.5. If I go from 0 to 2, it is 0.3. So the answer is 0.3, right? Because 0.3 is greater than 0.25. Okay, and another one is n is equal to 3 and ages is, oh, here node is 3, but oh, okay, so it means that the graph can be unconnected as well. It doesn't have to be connected graph, it can be unconnected graph. Here I cannot go from 1 to 2 or 0 to 2. So if the start is 0 and end is 2, I can see that there is no any path from 1 to 2 or 0 to 2, like 2 is not connected to anything. So that is why in such case output will be 0. If there is no path, then it returns 0. Okay, nice. So I think that we need to create a graph for this one so that we know where we can go. So what we can do is, we have ages, right? if I am copying, oh sorry, we have ages. So if I am copying the ages, then I just need to know. So from 0, where can I go? I can go to 1, and I can go to 2. From 1, where can I go? From 1 I can go to 0, and I can go to 2. From 2, where can I go? From 2 I can go to 0 again and 1, right? So okay, this is my adjacence. This is my graph, basically, you can say. So this, so if we start, what we can do is we can just start from start and end at 2. So if I start at 0, okay, I will start at 0, and from 0 I can go to 1. So what I can do is I can also add success probability here along with the node that I'm traversing to. So from 0 while traversing to 1, success probability is 0.5. From 0 to 2 it is 0.3. so that's what I'm adding. So that way I will know, right? From 0 to 1 it is 0.5. okay, nice. And from 1 to 0 again, because I will not go to 0 again. So from 1 to 2, nice, I can go from 1 to 2, right? So, and from 1 to 2 it is 0.5. so I'll multiply it to 0.5, and yeah, I think that way I can do it that way. So I will just keep on traversing until I will find the end. So whenever I find the end, I will write that probability is minimum probability is this one, is 0.25, because I found this one, and since I found 2, I will not go any further. Now I will go from 0 to 2. Now 0.2, I already found 2, so now I will look at 0.3. since 0.25 is less, so I will not update minimum probability. So that's what I'm thinking, So suppose from 0 there is 1. Suppose I'm just saying is something like this, right? So from 1 I'm going to 3. I'll also go to suppose 2. So after reaching at 2, I will come back, and for every point position I'll look at all the children. From 3 I went to 2, right? So if there is another path, I will look at that path as well. So from 0 I can go to 1, 3, 2. okay, I will see what is the probability of 0, 1, 3, 2. I will update minimum probability that way, and I will again go from 0, 1, 3, 2. After I look at this path, I will again go back to 3 and look at 3, 8, 2, this path as well. So this way I look at all the paths. So it is basically depth first traversal, because I'm first of all looking at all the children, and then I'm coming back and looking at another children. After looking at 3, I can go back and look at another children. So yeah, and you know what I can do is, suppose if the minimum probability I found is 0.25, and if I and when I go from 3 to 8 and minimum and probability is already greater than the minimum probability, then I'll not go further. That also one thing I can do. So while traversing this graph, what I mean is, while traversing this graph, when I come to a point where probability is less than minimum, greater than minimum probability, then there is no point in traversing further to get to 2, right? Because even if I get to 2, then it will always be, or no, because if I'm multiplying, then yeah, actually, because if I'm multiplying, so suppose I have 0.5 until 8, and this is greater than 0.25, because if I'm multiplying, then it will always be, but I want maximum, isn't it? So since I want maximum, so it means that what I do is probability at that point. This is one return condition, you know, this is one base condition. So if probability at that point is if that is greater than or less than minimum probability, suppose if it is 0.1, okay, if it is less than minimum probability, maximum, if probability at that point is already less, then if I multiply with some number, then it will even be less, right? So but I'm trying to find the maximum probability. So 0.5 is fine. If I multiply from 0.5, then it will be even less. So yeah, so this is one base condition, and another base condition is when that point is the end point. Yeah, that's it. When that point is the end point, then I will just update maximum probability. Yeah, I think this is it actually. So let me code. So first of all, I need to build the adjacency list, right? So let me do that. So another thing is, while building adjacency list and while traversing, what I also need to keep in mind is, so because from 0 there is 1 to 2, right? So if I'm drawing a graph for this one, from 0 I can go to 1 and I can go to 2, and from 1 I can go to, from 1 I can go to 0, I mean from 1 I can go to here, I can see that from 0 again and 2 again, right? So I need to be careful here that I'll not go visit 0 again, right? So for that I need to keep track of some visited sort of array set or something, because I would not want to I wouldn't want to go from 0 to 1, 1 to 0, 0 to 1 again. Yeah, so I will keep track of visited nodes. So suppose if I'm here from 0 to 1, then the visited nodes will be 0 and 1, right? So if 1 has children 0, then since 0 is already visited, so I'll not look at this one, I'll look at 2. So when I come back from 2, then I'll visited so when I'm backtracking and going back to node, when going back to parent node, just remove that node from visited, right? So if I'm going from 1 to, so what I'm saying is, from 0, when I'm at point 1, 0 and 1 is in visited, right? So if I'm traversing, if I've completed traversing all the children of node 1, and if I'm going back to 0 node, then I would not want to then 1 would not be visited at that point, right? Because I would be at 0. So I will need to remove 1. So it means that after I have completed traversing 1, that node, and going back to parent, then I need to remove that node. Okay, nice. So suppose make create, what is this, create graph adjacency list. So this is my adjacency. Suppose I've created this, and then after creating adjacency list named graph, then what will I do? Then I also want to have visited, right? Visited is set, and then because I'm iterating, maybe I need a helper function, dfs or something. And what will this dfs have? And I think I also need a maximum probability, right? So what will be a maximum probability? If it is less than maximum probability, I think it will be 0 in the beginning. Yeah, because I need to return 0 at last. So maximum probability is 0 in the beginning, and I'm going from 0 to 1, 1 to 3, 4, 5. So how will I traverse? From 0, 1, like am I using recursion here? Because from 0 I am going to all the children. So here what I am doing is, so this will be a node, one node, and I'll just say that let children is equal to graph node, right? So this will give me return this children. So after I find the children, then I'll need to look at all the children, right? So for const child of children, what I need to do is, I need to check if, so this will be in my children, isn't it? Suppose if I'm looking at 1, then 0 will also be at a children. So this will be first one will be child, and second one will be child success probability, because this will be an array. So okay, so if visited has child, so only if it is not in visited, then I will do that, right? If it is not visited, then only I will look at another one, otherwise I will not do that. I guess I should also add visited.add node here. So whenever I look at any node 0, then I am adding it to visited. So I am adding it first to visited set 0, and then I am looking at children. So this will be my children, and this will 1 will be my child, and 0.5 will be child success probability. So if it is not in visited, then I'm so should I do something with child success probability here? Or should I pass success probability? What I can do is, first of all success probability will be 1, right? I think that what I can do is success probability multiplied by child success probability, right? So when I'm passing child, so what I am passing here is, it will be DFS for node 1, right? Node 1 and 1 into 0.5 is 0.5. So when I reach here, then I'll know, so when I've reached here, I'll know that I've reached node 1, and while reaching node 1 my success probability is 0.5. so that is what I'm doing. So it means that at this point now I need to see if success probability, if it is success probability at this point is less than, if it is less than maximum probability, then what I need to do, then return, then I should not perform anything further. Yeah, that's true. And another point is, if node is equal to, right? So what if node is equal to endpoint? If node is equal to endpoint, then if node is equal to end, then what should I do? Then endpoint, then I should update maximum probability, right? So maximum probability is equal to math.maximum of maximum probability comma success probability. So whatever the value here is, so suppose if I'm looking at, suppose this is 2, okay, suppose I reached at node 2 and success probability 0.3, right, at this point. So what I would do is, since node is equal to end, I would just update this to 0.3 and then return. I don't even need to return actually, like returning would be better, because I would not want to do it more. And another thing is, I also need to, after I finish traversing, I'd also want to remove from visited, right? Visited.delete. Is this how we delete from set? So it means that after I look at all the, after I have finished traversing that node and its children, I need to delete from node, from visited set. Is this how we delete from visited? I'm not sure. I mean, sorry, from set. Oh, suppose a is equal to new set and a dot add 1, then now how can I delete? Oh nice, that's how we delete. I think this would work, right? So let's see. First of all, I have not created adjacent list. Okay, I will do this. Before that, let's see if this will work. Suppose I have adjacent list this one, then first of all it will call start, it will be 0 and success probability will be 1 at that point. Okay, success probability will be 1 at that point, and from 0 to, yeah, I was also trying to see condition where start not connected to end. Okay, so where was I'll also see this condition later, but first of all I was looking at from 0 to, when I go from 0 to 1, then so this will be, this node will be 1 and success probability will be 1 in the beginning, right? When I just started, I have reached node 0 and success probability at the beginning is node 1. So success probability is not less than maximum probability, 1 is not less than 0, so it will not return, and node is also not in, so it will not return. I'll add this node to visited, and now children will be graph node, so it will be this will be my children, and I am looping through that my children, so this will be my first child 1. After I complete looping through 1, then I will go to 2. I mean, after I complete looking at 1, then I will look at another child. So this is a whole depth first search, because only if after I complete this, then I will look at this, right? And after I finish looking at all the children, like in the for loop 1 and 4 and everything, then I will so if I see this, suppose I'm at 3, and if I finish looping at 2 and 8 all everything, then I will return to 1. So yeah, at that point I will delete this. So okay, when so here I was at 0, right? So so first of all I would loop at 1, since visited is not at 1, so I will now pass 1 and success probability into child probability, so 1 into 0.5 is 0.5. So now we have reached at node 1 and probability has increased to 0.5, decreased to 0.5. Now from 1 again, success probability is not less than maximum probability and node is not equal to n, so I will add visited is 1 and children will be now equal to 0, 2, right? It will also have its success probability as well, something yeah. So since 0 will already been visited, so it will not call this one, and for 2 it will call. So now it is that node 2 and success probability will be at this point 0.25, and yeah, and at this point I have reached node is equal to n, so I will obtain maximum probability. Yeah, that's fine, I think. Okay, and what about this case? See, condition with start is not connected to end. I think so at this point, right? So I need to go from 0 to 2 and maximum probability 0. So actually what happens is I will never reach end while going from, if it is not connected. Since I will never reach the end, maximum probability will never be updated. I will traverse the whole tree, but maximum probability will never be updated. At that case, maximum probability will be 0. Yeah, actually I think that this would work. Oh, sorry, I have not created an adjacency list, so let me create adjacency list for constant age of ages. From 0 to 1. Okay, for constant age of ages, graph A is equal to, actually what I should do is because I also need a success probability, so rather than doing this, for I is equal to 0, I is less than n, I plus plus. So what I can do is A to B each is I, right? And success probability for that age is success probability of given age is success probability of I, right? So what I need to do is I need to add graph A will be equal to graph A before that what I can do is I can just instantiated here. I just instantiated a graph. So here what I can do is I can just push B comma success probabilities, and similarly even for B also it's the same thing. Okay, this is it, I think. Sorry. Yeah, I think yeah, this would create an adjacency list, right? A, B and success probabilities. Undefined is not an iterable. Why I'm given ages? Is age is not a array? Undirected is connecting with the probability of what? It is a list, right? Of n nodes, 0th index. What's the matter? It does not because of that. Ages is fine. Age is 0. Nice. Age is 0 is also coming up, but for late I is equal to 0, I is less than I plus plus. Why is it this coming this way? Console.log I. What? Ah, okay, I see what's happening here. Zero is 1. Oh, 0 is 0 1 but why is it I has started from 0 and I is less than n, right? So I do not know why it is repeating. Like, what's happening, dude? Why is it repeating so many times? So is the way how I'm assigning this uh, wrong? Because why is it from 0 1 2 0 1 2 0 1 at last undefined? So I mean, why I'm just looping from 0 to so suppose, so at this time, this n is 3, right? At this point it should have stopped at 0 0 1 2. Why is it trying to loop from 0 again? So I is equal to 0, I is less than n, I plus plus constant a. So it is I is 0 and 1. Let me also try to log a and b. What's going on? Oh, this is fine. A and b 0 1 1 1 and 2. Okay, looks good to me. A and b is also fine, and success of probability is also, I think this is also fine, right? What's wrong? Like from 0 to I plus plus I is less than n, graph I is equal to empty. So it is, first of all, it is an empty array. So graph 0 is also empty, graph 1 is also empty, everything is empty. And then I will push graph 0 dot push b comma success probability is. So if we are looking at this one, then first of all it will be, so this is how my graph will look like, right? So first of all 0 will be empty and 1 will be empty, 2 will be empty in the beginning, right? This is what graph will do, because n is equal to 3. So 0 1 2, it will be empty in the beginning. And when I'm looking at this one, what it will do is a will be 0 and b will be 1, and success probability will be 0.5, right? This one. So it will do it will push graph 0. This will return empty array, so it will push 1 comma success probability is 0.5, and it will push 0 comma 0.5. That's what I'm trying to do. Like, let me console that log graph here. Nice. So if you see, then this is fine, right? This is what it is doing. First of all 0, and then it is pushing 0 1 0 5, then 0 0.5, and then 2 is empty. That's good. Zero 1.05 to 0.3. I think everything is looking good, but is my for loop not? What the hell? Like, what's wrong here? Why is it looping on, like, why is it looping too many times? I'm really not sure, like, my code. What is wrong here? Let me look at for let I is equal to 0 as less than n, I plus plus a b is I, graph is equal to empty in the beginning, graph I is equal to empty array, and a b constant. I mean, even if I use let, it's the same thing, right? Because at every loop this will change. Yeah, that's not the problem. Success probability. Actually, I have not tried to log success probability is, but that should not be a problem. See, 0.5, 0.5, 0.2. This is good. It is coming fine. What? 0.5, 0.5, 0.2, and 0.5, 0.5, 0.3. For which question? For this question, right? Ages and success probability up to 0.2. Oh. Why is success probability coming 0.3 for 1 is? So 0, this is 0 1 2, right? 0 1 2. So why is 0.3 coming here? Main thing is that why is it not ending? Like, what's wrong? This is for loop. It's for loop ending properly. What's wrong? For I is equal to 0 is less than n, I plus plus. Why is this for loop not working? Like when I come at 2 then it should have stopped. So funny. First of all I 0, then 1, then 2. Why is it not stopping? Why is this for loop not exiting after this one? Why is I going back to 0 after 2? Have I changed I somewhere? No, I have not changed the value of I anywhere. Let me try and I know that is of no, that will not help, I know that. Yeah, of course. Just changing the variable name. Like, this is what's going on? Like if I, you know what, if I remove all of these then it will end this loop properly. See, it only went up to 0, 1 and 2, but if I add these things, so let's try and see. Okay, okay. This dude here, this is causing the problem. Why? Okay, I think that it is because okay, I think that I see now, because of the array actually, because here 0, 1, 2, right? Like I'm just guessing, okay? So A and B value will be equal to ages I 0 and 1, right? So this will be equal to like this, ages I. So ages 0 will be assigned to 0 and 1, okay? And so if ages 0 is assigned to 0, 1, then at next point you know what, the problem will be solved if what I do is ages I and I'm 100% sure that this will fix this issue. No? What? I told that I was 100% sure, but I'm kind of happy because Now I know that there is not something about array that I do not know. If this worked, then it would have been more difficult for me to find out what was wrong, what information about array did I not know. But I think something is amiss here. Like, what is happening? Is this? Let me try, okay? Does this happen normally also or not? What should I try? G. What's the name? JavaScript. Oh my god, I'm already crossing like 1 hour. Like I'm about to cross 1 hour. This is too much. Oh, what? What the hell is happening here? Like this is exactly the same code, dude. I think that this is some kind of compiler issue now, like LeetCode's compiler issue. I'm starting to believe that. I'll not say that I'm 100% sure though. Not really, I'll just add up to this much only. Oh wow, see, it's the same code. It's the same code, but it is only printing from 0. I mean from 0 to 2. Okay, so I will just try to Control Shift refresh. What? Come on, LeetCode. Don't start to throw such errors. I'm just hoping that you will be fine now. You will work now. Still? What is happening? What should I do now? What I'll do is I'll just show you guys that this will work. I'll copy everything. If you see, this is returning 0.25. This is returning 0.25 and the answer is 0.25 for this one. This is returning 0.3 and the answer is 0.3 for this one. It should return 0. Oh, okay, I see. Is that the issue? Undefined is not iterable. Okay, I see. Nice, like it should have shown at this point only. Oh, okay. Oh, actually there are 3 test cases here that was running. So this was for test case 1, this was for test case 2, and this was for test case 3. And test case 3 was what was failing. Okay, got it. I don't need to console log now. Okay, so I'll just fix this issue now. So it was for this one, right? So edges, there are 3 edges, but there is just one. Yeah, there are 3 nodes, but there is just one edge. So what I should do is in this case, just say that edges dot length actually. Yeah, and even for this one, yeah, for this one it's fine. Now it should run. I did not consider for all the test cases, so I just thought that there was one test case here. Time will exceeded 11 or 10 test case passed. So what can I do to optimize here? what can I do to optimize this one? I need to go to all the ways, right, from 0 to 1 4. Oh, I think instead of going DFS, could I have gone BFS? All the nodes that is instantly reachable from 1, then 4, and after I finish this first node, then I could have looked at another one, then another one, then another one. But I'll try to optimize DFS solution. So how can I optimize the DFS solution? Is there any optimization? So from 0 I am going to 2, and then again I am going to, and this branch I'm going all the way. Nice, LeetCode has brought so many new features, cool features. I can use this test case. Okay, there are so many children. What can I do for such condition? From 0 to 1, from 1 to 2. Oh, let me think. I'm so sleepy. I'll just try to look at solution. I did not even think of the optimized solution because I want to sleep. Bellman-Ford algorithm. It was the shortest path faster algorithm. Okay, nice. Another one. Why is this laptop not going? My laptop is hanging. Another one is Dijkstra's algorithm. Oh, nice. Why are there all algorithms for this question? So in Dijkstra's algorithm, we start from the starting node start. Consider its neighbor one by one, updating the probability to each neighboring node. If the probability of reaching next node through current node is higher than the previous stored probability of reaching next node by other paths, in order to always select the node with the highest reaching probability, we use a priority queue to store the nodes to visit, where the node with the highest probability of being reached from the starting node has the highest priority. Okay, so it means that from 0, if I go to 1, and it will always be stored, right? So because um, from 0 to 0 it is 1, from 0 to 1 it is 0.8, from 1 to 2 it is 0.8. What's happening? Initialize a asset scene to keep track of nodes that have been visited, a priority queue to store nodes that need to be visited, and an array to store the maximum probability to reach each node from the starting node. Or the starting node and the probability to the priority queue. If PQ is not empty, remove current node, the node with the highest priority from it. From each neighbor of the current node, calculate the probability of traveling from starting node to the next node through current is, and update the maximum probability of next node if necessary. Compare the product of the probability, the maximum probability. Okay. So it means that at every node there will be a probability, initial probability for every node, and we will keep on updating the probability of that node. So first of all, 0 will have probability of 1, and 1 will have probability of 0.8, and 2 will have a probability of 0.8, and 3 will have probability of 0.8. So Dijkstra's algorithm is normally we update the maximum probability of this neighbor node and add this neighbor node to the queue. Oh, nice. This gives us the probability of reaching neighbor node through the current edge. We will repeatedly adding the same node back to the queue cause infinite loop and more. Initialize an empty queue to store nodes that need to be visited. Initialize an array to store the maximum probability of reaching each node from the starting node. Set the probability of the starting node as 1 and the probability of all nodes or all other nodes as 0. For each neighbor of next node. Calculate the probability of traveling from nice. Okay, I should have done it using Q, not. Okay, fine. My laptop's battery is also draining. Charge my laptop quickly, and while charging I also want to buy. I made this video after a long time, really long time, and I think I did not do pretty I did not do well solving this problem, and I'm also taking a lot of time to understand all these algorithms. But anyway,